This is a review of how you graph parabolas in the three forms that we talked about in class. We discussed standard form, vertex form, and intercept form. So what I'm going to do in this video is I'm going to go through one example of each form and get you used to what you do for each form, how the calculator helps you, and then ultimately what are the things that you have to answer about each particular graph. So the first one we're looking at is standard form. The reason that you know it's standard form is because there are no parentheses. That's the most obvious feature of a standard form equation of a parabola. It's just you have your x squared, you have your x's, you have your numbers. There are no parentheses whatsoever. First thing that's going to be asked on every single parabola question is, does it open up or down? The way you answer this question is you look at the very first coefficient, you look at that a value we call it, and we see if it's positive or negative. Because this is negative, this is a parabola that opens down. The next thing that you'll be asked is this parabola wider or narrower than your basic x squared graph? That also comes from the first number. Here you don't worry about the negative. You can completely ignore the negative. What you're looking at is in front of the x squared, do you have a number that is bigger than 1? That makes it narrower. Is it less than 1? That makes it wider. Or is it equal to 1? Like you just have an x squared. That makes it the exact same width. So this one, ignoring the negative, you have a 2 in front of your x squared. That is bigger than 1. That makes it a narrower graph. Now, the nice thing about these questions is you have a calculator. So every single time you are asked to do one of these problems, graph it on your calculator. We're going to do that in a second, and verify these answers that you're writing down. Finally, we need to find the vertex. And the vertex in standard form comes from one formula. The formula is negative b, or the opposite of b, over 2a. What that means is you take the opposite of the b value. The b value is in front of the x. The opposite of 8 is negative 8. And then you divide it by 2 times the a value. The a value is in front of the x squared, so the a value is negative 2. So we have negative 8 over negative 4, we get 2. The reason this number is important is that it is the x coordinate of my vertex. So I now know my vertex is at the point 2 something. The way I find that something is now it's time to go to your calculator. We're going to pull out our calculator and we're going to graph our exact equation that we see. You're going to go to y equals, you want to make sure you're working with a blank screen, type in negative 2x squared plus 8x minus 5. Hit graph. And first thing you should notice is you see a parabola, and everything that you originally started talking about should hold true. So this parabola does open down. This parabola looks slightly skinnier than your regular x squared parabola. Your vertex, I believe the vertex has an x coordinate of 2. To find out for sure, you're going to use the value button. That is second and trace. We did this several times in class. Hit enter on the very first one value. You get to select whatever x value you want. I'm going to select 2. If you correctly found the x value, if 2 was right, then you should see the flashing cursor on your vertex, which you do see this flashing right there. It will tell you at the bottom of your calculator screen that the vertex is at the point 2, 3. So I'm going to go over here and I'm going to write 2, 3 as my vertex. The last thing you're going to be asked to list is the axis of symmetry. The axis of symmetry is a vertical line that goes right through the vertex and splits it into 2 equal pieces. Your axis of symmetry will always be x equals, because it's vertical, whatever number is the first number in your vertex. So this is x equals 2. That is a line that goes right through the vertex that splits the parabola into 2 equal pieces. When you go to graph it, nice thing about your calculator, let's say you want a few more points to make your graph accurate. We're already on this value button. I don't have to hit anything else. I can just pick a different x value. I picked 2. I could pick 3. So if I hit 3 and enter, that gives me another point on my graph. It tells me another point on my graph is 3, 1. I could pick 0. And it would tell me another point on my graph is 0, negative 5. So if I really want to be accurate, I could pick a whole bunch of points for x and get a lot of points along my parabola. I am not going to be very picky when it comes to graphing these. What I'm looking for is that your vertex is in the right place. So my vertex should be at the point 2, 3. It should be opening down. It should be narrower than your basic graph. So I'm looking that you draw something like this. That's it. I don't need to be more accurate, but you can get a few more points if you want it to be more accurate, but your vertex better be in the right place and you better be opening the correct way. That is standard form. The second form that we discussed was called intercept form. Vertex form. Vertex form is the easiest of the 3 forms. When you do vertex form, you're still going to be asked the same questions. Does it open up or down? Again, it's coming from the number in front here. It's a positive number, so it opens up. You'll be asked if it is wider or narrower than your basic x squared graph. Because 1/4 is less than 1, it is wider. Your vertex is much, much easier for this one. It's actually very similar to what we did with absolute values earlier in the course. Your vertex is the opposite of what is in parentheses. So instead of -5, it is 5, comma, whatever number is outside being added or subtracted on the end. So your vertex for this one is just the point 5, 3. If you forget this, you can look at it in your calculator and confirm that. So when I graph it on my graph, I'm going to go over 5, up 3, and put my vertex. Again, to check it on your calculator, we're going to type this one in to get practice. You want to make sure you type in every single one on the quiz to make sure that all your graphs are accurate. So 1/4, parentheses, x minus 5 squared plus 3, hit graph. We should see a parabola that opens up. It should be very wide compared to our previous one. It should have a vertex at 5, 3. If I want to double check that, I'm going to do second trace to get to that menu. Hit value of 5. And that cursor should be flashing at your vertex. If it's flashing anywhere else in your parabola, you know you have the wrong value for your vertex. My axis of symmetry is always x equals whatever this first number is. So this is x equals 5, and all I'm expecting on your graph is that you have a fairly wide graph opening up with the correct vertex. The third and final type is called intercept form. What is special about intercept form is it is made up of two individual factors that are in parentheses. Another name for intercept form is called factored form because it would have been what we did earlier in the course with factoring. When you start with these, same initial questions, up or down, this one will open up because the initial number in front is a positive 2. It is narrower than your basic x squared graph because the number a is 2. 2 is bigger than 1, so that makes it narrower. This is a little different. Instead of getting vertex right away, what you're going to get instead is you're going to get the intercepts, or where it crosses the x-axis. And that is going to come from these two factors. You find the solutions of the factors, just like we did on the factoring chapter. The solutions for the first one is what makes x minus 1 equal 0, and that's when x equals 1. The solution of the second factor is what makes x minus 5 equal 0, and that's x equals 5. What these points represent are the two places where the parabola crosses the x-axis, so a point at 1 and a point at 5. Your vertex is going to be directly in between those points. So you could either put one finger on each point and just gradually move closer and closer together until your fingers are together, or mathematically you're going to average the two x's that you have. So if you get an average between 1 and 5, what you do is you add 1 and 5 together and cut it in half. So 1 plus 5 is 6, divided by 2 is 3. So that tells me that my vertex has an x-coordinate of 3 because it's directly in the middle of the intercepts. Again, to find the y value, the fastest, most accurate way to do it is make the calculator do it for you. We're going to go to y equals, put this graph in, so 2, and then in parentheses we're going to put x minus 1. And then in another parentheses we're going to put x minus 5. Hit graph. You should see a parabola that opens up, that crosses the x-axis at 1 and 5, that is skinnier than your basic x squared graph. So everything that you see visually should confirm what we've been writing. We want to find the vertex, so for the final time I'm going to use that value button, and I'm going to type in 3. You can kind of barely see it on the screen because it's pretty low. It is flashing down there on the vertex. The vertex is the point 3, 8. So on my graph, I'm going to graph 3, 8. This one is even easier to graph because now you have so many points to make it more accurate. We're going to go up through this intercept. We're going to go up through this intercept. Finally, my axis of symmetry is always x equals whatever the x value is in the vertex. In this case, it's x equals 3. Make sure you don't just write the number 3. You have to write x equals because that tells you that it's a line. X equals 3 is a vertical line. What it would be, if you want to see what it looks like on your graph, it is this line right here that splits the parabola into two equal pieces. This is how you graph any parabola. You just have to determine the form. Again, we have standard, vertex, and intercept, and then use these steps to correctly graph and use your calculator to make sure that everything is making sense.